Hi, everyone. Welcome. Today, I will talk about integrating AI with Postgres, and I will mention how Postgres is a great and how it is a perfect way, in a perfect way, it is positioned to be the AI database and why we need it. First, about me. I'm not really from the Postgres community. My background is CS and AI in general. I did my bachelor in CS, then completed with a text-to-speech thesis, and then moved into master's degree. I did fraud detection in there, and thesis again, and then moved into PhD. And here I am, as a machine learning engineer in EDB. What else about me? Yeah, I'm one of the organizers of DevaConf, along with one of the co-organizers of this conference, who is Gülçin Yıldırım Jelinek. And in my free time, I do Muay Thai for the last 10 years, and I'm running. Okay. This question is not probably for you. This is for people like me, actually. What is Postgres for an AI engineer? What is Postgres for a developer who wants to develop AI application? Postgres is great. That's perfect. It's out of the discussion. But it is traditionally powerful relational database and nothing else. It's not the first thing for someone who wants to develop an AI application to go and build an AI application using Postgres. It's not something for an AI engineer or researcher as the first database to go and develop AI application as well. Before EDB, it wasn't mine, at least. But why we need AI in Postgres, right? This can be another question that we need to ask to ourselves. Okay. This is how data has evolved over the years. Postgres is a great relational database that fits the structured data very well, but over the years, the data has grown on unstructured data, and in the industry today, more than 80% of the data is unstructured data overall. So Postgres needs to evolve as well to be able to handle unstructured data. And at least that's what VectorDBs claim today. I want us to be in the same common ground about AI, because I don't think everybody is talking about the same thing when they are talking about AI. Therefore, I just wanted to give a brief introduction, what is this? Facts that I'm going to talk about, it is based upon. First of all, it used to be, there was traditional machine learning back then. In traditional machine learning, the data was often structured, and we used to train those traditional machine learning algorithms specifically for the task that they're going to run on. And they weren't perfect, they weren't great as it is today. And therefore, it was merely research topic at the past, but it is not today. Today, the data is mostly unsupervised, and the large language models or the AI models, it doesn't have to be only large language models. They are trained on, work on, generate unstructured data, or text data, let's say, or image, which is, again, unstructured data. Okay. But what is an LLM, or what is language models? What is language AI models? These models, or when people talk about AI models, they often refer LLMs. That's why I just want to give the brief introduction about these LLMs. What is language AI models? What does language AI models is that it processes the input text. These input texts can be in different forms, and as an output, it can generate more than multiple things. Like it can generate a text output just as you use ChatGPT, just as you use GPT-4, Claude, even DeepSeek today, like everybody's talking about, right? And they can generate embeddings. Embeddings are nothing but floating points, a list of floating points that represent semantically of the given text data. Or they can do classification. They can do something like classifying of the given mail, whether it's spam or not spam. It's called HEM. I'm pushing the different button every single time. Okay, but to be able to, for language models, to be able to understand the data that is given, because language model is nothing but a neural network, and neural network connections is nothing but a mathematical formula. So you can't give the text data directly, or you can't give the image or even video data directly. You need to process them. You need to represent them so that the neural network can understand. So it can be, as you can see on the top left, it can be a document, a full document of text. Or it can be a sentence. It can be tokens. Tokens doesn't have to be word in a given sentence, but it can be. It depends on the corpora. It depends on the database that the model, while training, is used. And as you can see, her vocalization was melodic, and the vocal and ization are two different tokens as an input. And as an output, this representation models can generate a full document embedding, that this document embedding can be considered as a summarization of the document that represents semantically of that document, what that document is talking about. Or it can be sentence embedding, or a token, or a word embedding. These two are two different things. Okay, I just wanted to try to be in the common ground so that we can move forward how data and these models are connected and how even Postgres is connected as a database. We have AI data. This AI data is, as we talked, often unstructured. This AI data can be image, can be video, voice, text data, a PDF document, or even structured data. And each one of them needs a special, certain type of transformer model that can transform this data, that can represent this data in the format that AI models can understand. So each one has different transformer for that reason. As a result, embeddings vectors has been generated, but these generated embedding vectors needs to be stored somewhere. Then later that they can be used. And this is nothing but a vector DB, right? That the first thing comes to your mind. And this can be Postgres as well, with the help of pgvector. Okay, the question becomes in another form. What is Postgres after pgvector extension? How many of you heard about pgvector extension? I'm sure like majority. How many of you used that before? Okay, good. For those who don't know, pgvector extension is a PostgreSQL extension that allows you to do vector indexing and operations like similarity search. And of course, it allows you to store it in the special format in the Postgres. So pgvector comes into, when pgvector comes into play, the bridge is started to gap for Postgres to be an AI database. Because pgvector is an extension that allows you to transform, index, do the similarity search in Postgres. These two are the main capability that pgvector brings in our life into Postgres. One is vector indexing. There are two types of vector indexing today in pgvector comes in, which is HNSW and IVF flat, and the other one is similarity search. But these two are not still enough. It starts to bridge the gap, but there's still a big gap. Because, I don't know how many of you heard about Andrew Ng, but he is one of the co-founder of Coursera, Deep Learning AI, and a professor at Stanford. And he's one of the known person in AI field that Times has introduced this year. And he has given a talk lately and has said that this year is going to be AI Builders Year. And AI Builders Year means that developers, at the past, it was researchers' field that to develop AI applications. But today, it's different. Developers will and are doing the AI application, developing the AI application. So this year, we will see even more applications that will use AI. And that's why we need to make it simpler. We need to make it more accessible for those who want to build AI applications. And pgvector has some limitations about that. Because in the end of the day, you need to generate those embeddings. Yeah, pgvector helps you to store them, but then it also does the distance calculation, similarity search in other words, but nothing else. To generating those embeddings is also another work and can be a complex work as well to maintain it, to generate it, to store it in a certain format, to transform it as well. Okay. Everybody knows chatbots, right? Every company has at least one, and every company has one even more, and we will see an explosion this year. Even more chatbots, this means. And this is the first application comes into your mind probably when, at least today, when someone says an AI application. But how is it working? So, as a first step, you're storing AI data. This can be unstructured, this can be structured, but they need to be stored somewhere. And you need a vector database as well, but it should be in a close distance. It should communicate seamlessly with the stored AI data so that they can talk for the chatbot application. Okay, we have the vector database, we have the AI data store, and there is the encoder-only LLM, a large language model that can generate embeddings as an output, and they're talking together. So data and vector cannot be separated in other way. They need to be close. Then you have a UI, you're getting the user requests, you're getting the user queries, and users typing the queries. I don't know, what is today like? You're getting that plain text and send it to the same encoder-only LLM to generate embeddings so that the distance can be calculated between them, between the already stored vector data and the data you have received. And in the end, you retrieve the relevant data. This relevant data is a plain text data, not vector. You're sending it to a decoder-only LLM, which can be a GPT-4, which can be Claude, which can be DeepSeek, and returning the result according to the information that you provided to this decoder-only LLM. So this is RAG, and this is how a simple RAG works. So, as I said, Postgres has a great potential to be the AI database because it has a huge community behind its back. It has already enterprise-level data. It serves quality of service. It ticks everything except the AI capability. So it brings me one extension that provides this AI capability, which is aidb that EDB has been developing, which is not open source yet, but we're working on it. But there are other extensions as well out there that you can look for it in as similar capabilities, if not the same. Okay, what do we need to develop an AI application in a full stack? You need multiple things. Like, first of all, you need to capture the document. You need to store the data in somewhere. It can be an object storage. It can be a Postgres table. You need document preparation, which means that once you upload the PDF data, it needs to extract the data so that it can process, or an image. Then you need the embedding generation. Then there's vector indexing, which, of course, we're using pgvector for that. And there's the user query embedding generation, if you consider the RAG workflow that we have just talked. And there's the similarity search again. pgvector is already providing that. And there's the retrieval part, augmented text part that we have been sending to the decoder LLM to get an answer. And there's the generation part. And it's not only about that. There's even more to develop a full AI database or a full AI extension. OK, this was what pgvector was providing to us. And in the end, this is what aidb has been providing for us. Like, it's covering all the tick boxes. Well, another application example, I just want to talk to you about something similar to eBay, for example. Like, consider you have implemented a web application similar to eBay, and it has two capabilities. One is getting a text search from a user. The other one is getting image from a user to find the similar ones, and in the end, recommend items or shopping items that user can buy. And how can you implement this using pgvector? And here is the answer. I don't know if you remember, we have just talked, but I will repeat myself. We have the AI data. Then we have the special transformers. We can call them embedding models at the moment. And then they're generating embedding outputs, and we're storing them in Postgres with the help of pgvector. And those inputs have been generated and stored in the Postgres. Then once your user have seen, it can be me, like, for example, I went to a friend's house and seen a cat figurine, and I want the same one. Then what I'm going to do is uploading that image that I have seen it in a friend's house, and then this image is the one that I have uploaded, and this is using the same image transformer that I have been used in here to generate embeddings so that they can talk in the same language. If you use different models, for example, for the input of the database or the user input, then they're not same, they're not compatible. The distance you will get will be wrong. In the end, I'm using pgvector at this point to calculate the distance and get the top, 10 outputs, top 2 outputs, to show the user that she can buy. These will be the figurines that user will see. And pick one of them, probably. What is aidb extension doing? aidb is doing. It's encapsulating everything we have seen just before slides, the previous slides. And aidb is handling the vector generation, indexing, handling the user input to generate the embedding again, and do the comparison, and sending the results in the end to the user. And let's look at how it is looking from inside. Like, this was the previous slide was great, like it's a black box, right? How it is looking from inside? What are the services that it is providing that gives you this capability? Okay, I will start from here, this object storage with images. At the first step, aidb connects to the object storage and retrieves the images, and then connects to the AI model serving platform, let's say. It can be Hugging Face, it can be OpenAI, you can use Ollama, whatever you want to use, but it is connecting to the AI model you have selected and generating the embeddings and fetching those embeddings. After that, storing the embeddings in Postgres with the help of pgvector. Now we have completed the first part. Our eBay-like website, Amazon-like website is ready to be used. It's going to accept user queries from now on. Then, the top in the user. Once the user connects to the recommendation engine application that you have built, it can upload an image or write a text to do the search. Either way, I have to return a result that will be interest for the user. And to do that, like on top, I can't see it, but aidb retriever service again fetches the input that the user has been providing, and then connecting to the AI model again to generate embedding, because to be able to calculate the distance, we need the embedding, and the embedding's distance calculation is providing us a semantically closer output. Then semantic search service, with the help of pgvector, is doing the search and getting the top closest similar k item, which can be 10, 2, 5, whatever. And then returning those results to the user. And let's see how it is working in a demo, which I have developed. Okay. This is the website. The data set that I have used is an open data set. It's called Fashion. It's in Kaggle, that you can find it easily. You can see that I have the shopping items, and now as a user, I'm typing something like sport shoe. And doing the text search, as a result, I'm getting top 5 item. These are the top 5 sport shoe item from different brands. And I have a couple of other examples in text. Like, for example, white shoe can return something which doesn't say white in the description, like in the bottom one. But this is, again, white. Let's move a little bit faster, because it will continue with the text as well. Okay, now I'm doing the image search. It is, again, similar. It gets the input either in text format or image format and generates the embeddings, and as a result does the similarity search and brings the top k item. Like this one is a bowl. That bowl is, this is the one I have selected. And these are the ones that have been fetched as the top similar items. I want to see you one more. Oh, OK, here's the example. It's not perfect. So it does semantic similarity, but it doesn't mean that it's perfect. It is going to bring the most perfect result. This is the backpack. Again, in here, we will see not only backpack, but also different type of bags, I think, if I don't remember correctly. Yeah, it does brought the only backpacks. OK. Well, this demo application has been developed both with pgvector and aidb itself. And this is the pgvector version. 132 lines of code, as you can see. I know Python, and therefore it's Python. OK. This is the initial part where we get the all items that we want to store in the database with their vectors. And in here, I can't see it, but probably you can see on top, there is the model initialization. Like I get the model and the processor. This part is like, it says it's a clip model, which is a multimodal, which means that it can process both text and image at the same time. Like as a single model, it can generate embeddings for both text and both image. So it even gets complicated because you should know which one you're going to use, or which embedding you're going to generate in the end, and how you should transform. Like in the arrows, you can see that I'm providing the input in a certain format, and then I'm asking image embedding specifically. And after that, I think, yeah, here, I'm transforming in here so that I can store it as pgvector. And this is the way to do the same thing with aidb. In aidb, all you have to do is creating an S3 retriever so that it can connect to S3, fetch all those images that you have stored, and generate embeddings with the model that you have selected, which is the clip model, again, that I'm providing in here. Then all you have to do is calling another function to generate those embeddings. And 132 lines of code is dropped into just 2 single function call. Then again, this must be the image search. In image search, again, you should use the same model, which is clip model in here. And again, you have to transform it in a certain format so that it can process the input, and then it needs to generate image embeddings. Then it needs to transform so that the similarity search can be run. This, again, a single function call with aidb, and it makes it easier to develop for someone who doesn't know the behind the scene, or who doesn't want to maintain this like 70 lines of code every single time, or 132 lines of code every single time, because it gives the same capability, but it brings simplicity to the table. This one is the image search. No, this one is the text search, because I'm asking for the text embeddings in here and transforming them, again, in a certain format so that I can do the similarity search using pgvector. This is the 55 lines of code, and it becomes, again, a single function call with aidb so that it can be retrieved. Well, to summarize, pgvector Postgres has evolved from being a purely relational database into a platform that supports advanced AI operations, which makes it a go-to database, let's say, for an AI engineer, which can make at least. And another point is data and vector are better together because there needs to be a seamless communication, seamless connection between them. pgvector has bridged the gap by bringing capabilities like vector indexing and semantic similarity search, but we need more than that to be able to make it more simple for those who want to develop AI application. Oops. OK. pgvector is a little bit hard to install. That's what I believe, at least. And I think we need to make it simpler and probably vocalize it more. So, thank you for listening. happy to answer any question.
So can you hear me? It was nice talk, and thank you very much. I have a question because I worked in my previous job in startup who created widget for prediction of sizes for online clothing shops.
I'm a little having hard time to hear.
So you cannot hear me?
Now I can.
Okay.
Better.
So I worked in startup where we created widget for predicting sizes of clothing for online shopping. Mm-hmm. And what you showed, it would be amazing, like for implementing style recommendation. But I was wondering if you were thinking also about this part, like predicting sizes based on AI, because there is like a huge movement around it, and we used just some machine learning algorithms, but did not think about AI yet in those days, of course.
What size?
Predicting size of clothing, for online shopping. You put height, weight, and your age and gender, and that engine was able to predict size, which is suitable for you. Did you also think about this?
But do you get weight?
Okay.
As an input, I mean.
Yeah, height, weight, gender, and age,
okay.
like input. Okay, so I'm probably unable to formulate it properly. I am not sure.
No. This requires predicting, which is also another topic, just like classification. Therefore, it needs certain type of models.
Yes, my question was if you would be able to combine it, because this AI prediction algorithm looks perfectly for style recommendation, which was like a huge problem for old machine learning models. But on the other hand, I'm wondering if this size prediction would be also easy for AI model which you showed.
Okay, now I get it. The size prediction is a different type of topic, and it probably requires, because it is changing, even the size prediction will change for US and EU and for different countries, right? Therefore, I believe it needs to, again, be trained with a prediction algorithm with the data set that you have so that it can generate specialized outputs. But I think today most LLM models are good at predicting these type of things so you can try and see it. Probably they will be good enough, if not perfect.
Mm-hmm. Okay, thank you.
Any other question?
Probably no. So
okay.
Thank you.
Thank you. I will be around if you have any other question. Anyway.